Hello, Math 10. We are doing some trigonometry. How very exciting. So, first of all, we're going to be taking a look at our various ratios and seeing how we can use our calculators to find out what the ratios are. Hopefully you watched the videos and you learned sort of what the trigonometric ratios are, what that means, and basically they're just sort of ratios of sides that happen to be the same. No matter what the size of a right triangle is, the ratio of the sides is always going to be the same. So for example, if you wanted to look up, say, the sine ratio for the angle 35 degrees, you could take your calculator, and I'll just open up a calculator. I'm trying to open up a calculator. Here we go. Start. Go. Calculator. There we go. Finally. So we open up a calculator. You can type in 35 degrees, and then you press the sine button on your calculator. So mine's hiding under here, and that tells me the ratio is 0.573576, etc. So I'm going to write that in here. 0.5735. I guess I'll round up to 6. So I'll put that in there. 0.5736. So that's the answer. So you might be wondering, what does that mean? Like, now that we have discovered that is the answer, what is that talking about? So just so you know, and in case it wasn't clear on the videos, the sine ratio is a ratio of two particular sides. In particular, I guess I'll go draw over here in the corner. Here's my bad triangle. Hope it doesn't suck too bad. Ooh. Yeah, it's pretty bad, but oh well. So let's say this is our 35-degree angle here. 35 degrees. So no matter what kind of triangle, what size right triangle we have, the opposite side, so if we go across from our angle, this is our opposite side, it's going to be, about 57% the size of our hypotenuse. That's sort of a diagram there. That's sort of the whole idea of the sine ratios. They sort of tell you a relationship between the two sides. So the sine ratio is the relationship between the opposite side and the hypotenuse. So we've discovered here that the opposite side is about 57% the size of the hypotenuse. So a little bit more than half. And that's just guaranteed to always be the case for every right triangle. No matter how big or how small it is, no matter how long the hypotenuse is, the opposite's going to be about 57% the same size of it. So you might be like, that's great, thanks. Thanks for the info on triangles. But it's surprising how often this comes up, and it is quite useful. We'll get more into that later on, but you probably want to get your homework done. So, basically this is similar. All these questions are the same. You type in your calculator 81, and you can type in and then the right ratio key, and find out what is the ratio of the sides. It gets a little bit different for question 2. For this question, they tell you the ratio, and they want to find out what the angle is. So you can look that up on your calculator. You could type in this ratio. So 63% is basically, pretty close to what that is, 63.5%. So they're asking, what angle would give you a ratio, like an opposite side that's about 63% of the hypotenuse. So that's where we can use the inverse functions. So I could type in, for example, 0.6348. And then what I'll do is I'll use, I have to type in second function, which is possibly what you have to do too. And then you can see sine -1. So this is the inverse sine, which is, it takes a ratio and turns it into an angle. The sine button takes an angle and turns it into a ratio. So they're sort of like opposites of each other. So I'll hit that, and it looks like it's 39.4 degrees. So I can go type in, oops, I didn't mean to put a dot there. 30, I don't know how to get that dot out of there, but oh well, this is embarrassing. Who cares? 39.4 degrees. So that's the answer. And you can just do sort of a similar process as for finding the angle. You're using the inverse calculation. For the next set of questions, for question 3, they are asking you to find a bunch of different pieces of information. So for example, they want to find, here we have 41 degrees. I'll switch over to the pencil here. They have 41 degrees in this corner, and they're asking what is alpha. You know this side is 10, and then we're trying to find x and z as well. Okay, so what are we going to do? First of all, finding this angle here, this is pronounced alpha. It's probably the easiest one. I can say that alpha is going to be basically, you know, the triangle adds up to 180 degrees. One of those is already 90, so the two other angles, it's not the square angle, are going to add up to 90 degrees. So alpha is going to be 90 degrees minus the other angle, so minus 41 degrees. Because those angles got to add up to 90. It's just the way triangles are, especially right triangles. These two have to add up. So then what's that going to be? I guess it's going to be about 49 degrees. So that's going to give us our answer here. So that wasn't too bad, right? They can use the property that angles in a triangle add up to 180, and of course one of them is already 90, so that's how we find that. Okay, so now we want to find, say, x. Can I erase this stuff here? I'm going to just try to erase it because we already solved it there. It's hard to erase, apparently. Almost. Try it again. Okay, pretty good. Okay, so now I'd like to find out maybe, let's say, z, the hypotenuse. So what information do I have? We could work from different directions. You could work from the alpha angle now that we have the 49, but I like to work from the one that's given to us. Just in case we got 49 wrong, let's say I just added it wrong, I'll stick with the 41 because that one's given. So I'll try to stick with that one. So what do I have? So if I'm using 41, I know I have the opposite side, that's 10, and I'm looking for the hypotenuse, that's z, it's the slanty side is one way to think of it, the one opposite the 90 degree angle. So what trigonometric ratio is going to help me here? So it turns out that's going to be sine, because sine is equal, sine of 41 degrees, we'll say, is equal to whatever the opposite over the hypotenuse is. That's just the ratio. And we already know what the opposite is. We can see that's 10. We still don't know what the hypotenuse is. I'm not sure why I'm getting such spiky letters there, but it's kind of cool. Sine of 41 degrees. So now, if I'm trying to solve for the hypotenuse, basically I can sort of cross multiply these guys here. And I can get an equation that says the hypotenuse is going to be 10 divided by whatever the sine of 41 degrees is. So I'll go ahead and put that into my calculator. So I'll do 10, oops, I'll clear first. 10 divided by 41 sine equals 15. Sounds good. So I'll put in 15.2 is going to be z. So one quick check to do with your hypotenuse is it should be the longest side. The hypotenuse is always the biggest side. So if it's not biggest, you made some kind of mistake. All right, so now what do we do? Well, now we're looking for x. Ooh, pardon me. So there's a number of ways to do that. I don't know. I guess I'm going to try to erase this. Oh, it's going to be so taking time. There's a couple ways to do this. You could use the Pythagorean theorem is one way. You could use other trig ratios. So it's sort of up to you how you want to do this, how to do this equation. So there's no terribly wrong way. I don't think there's any way that you can go too far wrong. So maybe I'll just stick with the trig ratios, and we'll see what I would do if I wanted to use trig ratios. So for example, I have 41 degrees. Maybe I'm looking for x, and now I have either the opposite or the hypotenuse, so I can use either one. I guess I'll go with opposite, because that one's given to me, right? So that's I like to use the numbers that are given to me in case I make a mistake. So I got opposite, and this would be the adjacent side. So which of the trigonometric ratios is opposite and adjacent? That's going to be tangent. So I can set up the tan ratio. So the tan ratio for 41 degrees is going to be opposite over adjacent. I can say that, without a doubt, I know my opposite side is 10. I'm still looking for the adjacent side, that's x. And tan of 41 degrees, I'll just look that up right now. Tan of 41 degrees. So I'll type in 41. Actually, I should clear it first. So 41 degrees. And trigonometric ratio is this time is tan. So that gives me 0.86928, blah, blah, blah. 0. I lost it. 0.86929, basically. 86929. It goes on. I think that's probably going to be sufficient. So because I just need it to one decimal place. So now I can cross multiply, and I get x equals 10 divided by that ratio, divided by 0.86929, ... So I'll just do that calculation. So let's clear, and I'll do 10 divided by, actually I'll just recalculate it, 41, 10 equals 11.5. So it's 11.5. So there you go. So that's how I did it. Could you have used cosine there? Yeah, sure you could have. No problem. You could use a variety of ways of solving the question, but there's an example of how you might go about solving it. So basically with trigonometry or the Pythagorean theorem, there are many ways to find all the edges and angles inside of a right triangle. So I'll leave you to try the other ones, but let me know if there's any problems that you can't solve or things that you're struggling with. I'd be happy to record a video to answer any of these questions. Okay? Hey, thanks so much. Math Dan, we'll see you soon. Bye-bye.